Welcome to this session. I am Dr. Anusha Kathyayani, Assistant Professor in Department of Chemistry, Institute of Aeronautical Engineering, Hyderabad. Today, we are going to discuss on the plastics. Then, the types of plastics, namely thermosetting plastics and thermoplastics. We are going to see in detail about these plastics. So, we are going to focus on what are the plastics, thermoplastic and thermosetting plastics and the difference between both with proper examples and what are the advantages of thermoplastic and what are the disadvantages of thermoplastic and what are the applications of thermoplastic as well as advantages, disadvantages and applications of thermosetting plastics. So we are going to see the difference, how they are going to differ in their structure and their molecular weight and the molecular structure and the application part. We are going to see in detail today. Plastic. The word plastic is derived from plasticose, which meaning mold. So they are easily applicable to mold. They can be molded easily. So the term is derived from the word plasticose, which is made to mold in Greek. So the fossil fuels have compounds containing hydrogen and carbon. So these polymers are generally the hydrocarbons, which act as the building blocks for long polymer molecules. So generally the fossil fuels which are buried under the earth for millions of years ago, they are the fossil fuels. They are generally consists of carbon and hydrogen compounds. So the term hydrocarbon. So the polymers is nothing but the hydrocarbon chains. So they join together and result in the formation of a polymer. So these building blocks are known as monomers. So they link together to form a long chain called polymers. So these are the monomers. They are the small units. So they join together by the bonds. See, they are joined together by the bonds forming a polymer chain. So this is polymer chain. These are single units called monomers, and if the monomers are joined by the units by the bonds, then it is called the polymers. So the plastics are synthetic, semi-synthetic, organic compound polymers and have the capability of being molded or shaped usually by the application of the external heat and pressure. So it may be the synthetic and semi-synthetic molecules which are ready to mold usually by applying the heat and pressure on that polymer. The property of plasticity and other special properties which include low density, low electrical conductivity, transparency, toughness and allows these plastics to made into a different materials or variety of products. So these special properties of the plastics giving the advantage of allowing the plastics to made into different variety of products. So these plastics are divided into two types, namely thermosetting and thermoset or thermoplastics. They are also called thermosetting plastics and thermoplastics. Now we are going to see how they are going to differ. The thermoplastics are used for manufacturing of toys, combs and various types of containers can be remolded after heating. So these thermoplastics are the name thermoplastics which can be molded, can be remolded. So which can be recycled are called thermoplastics. Thermosetting plastics are used for electrical switches, handles of various utensils as these plastics don't melt or mold or soften on heating. So here the thermoplastic means which can be molded or the recycling or remolding is possible with this thermoplastic polymers, whereas thermosettings, this once made the material or the product is made cannot be recycled, cannot be remolded or cannot be converted or heating, even on heating also. So here thermoplastics can be melted repeatedly. So these are thermoplastic. Thermosets, which are used in the electrical switches and utensils of various handles of various utensils, which cannot be remolded easily. Coming to the thermosetting plastics. These thermosetting plastics are made from long chains of molecules that are cross-linked. So suppose this is a linear chain of polymer. So there are three linear chains of polymer and A is the monomer unit. Especially in thermosetting plastics, there will be the cross links between these polymers. So the cross-linked polymers and long chains of molecules that are cross-linked, and this cross-links gives a rigid structure to the polymer. They can withstand high temperatures, and once hardened, this cannot be reformed or recycled. This withstand high temperature. This is why the reason we are using handles for the various utensils. These thermosetting plastics are used for handles because they can withstand high temperature and they are very rigid because of their cross-linking between the linear polymer chains. So the examples of thermoplastics are polystyrene, Teflon, acrylic and nylon. These are the thermoplastic polymers. These thermosetting polymers we are going to see. So the thermosetting polymers, once heated, thermosetting polymers can be molded, shaped and pressured into shapes. Once set, they cannot be reheated since they are permanently set. So as we know, the thermosetting polymers are once set, they cannot be recycled or reformed after the setting of the compound. So once heated, softens, then can be molded or shaped, then cooled, then it was rigid. It was fixed. We cannot change its shape even on the external pressure or the heat. They are the thermosetting plastics. So the thermoplastic materials are typically, they have low melting points due to which they can further be remolded or recycled easily. The thermoplastic materials, here the cycle is like heating. Before, in the last slide, we have seen the thermosetting plastic polymers. Now, this is thermoplastic materials. Heating, softens, cooling, molded. Once, if we don't want this compound, once molded, again heating, again it softens, again it cooling, again the process is like recycling. We can do the recycle of this polymers. They can be recycled easily, like these rubbers, bakelite, polyurethane, epoxy resin, vinyl ester resins. So the difference between the thermoplastic and thermosetting plastics. It is a type of plastics knowing its versatility because of its recyclability. From when repeating units are called monomers, link into chains or branches. Here a type of plastics which cannot be remolded or recycled due to its composite and rigid chemical structures because of the cross links between the linear polymer chains. They are also known as thermosets. These polymers generally consist of the cross links between the chains. Here the advantages are strength, lightweight, low processing cost and low melting point, and weaken adhesive bonds between the two linear molecules. This causes the recyclability and remolding process of these thermoplastics. Whereas in thermosettings, the strength, high heat resistant, hard and rigid, low initial viscosity causes the advantages of these thermosetting plastics. The compounds used in thermosets are reactive systems. Here commonly employed are PVC, polyethylene, PVC, polystyrene used for packaging application. Other groups are acrylics, fluoropolymers, polyesters, polyamides and nylons comes under the thermoplastic category. In unsaturated polyesters, phenolic and phenol formaldehyde PFs and polyurethanes and urea formaldehyde comes under the thermosetting plastic category, and these are considered to be favorable in plumbing and substitute for steel piping as a water pumping pipelines, and insulating electric cables at low pressure PE was used, and ropes and belts were polyamide was used, and electrical equipment high pressure polyethylene was used. It can be used in the manufacturing of mold, wide range of industry and used in applications because of their high heat resistant and high strength, and energy automotive appliances and electrical lighting and energy markets. So no recycling and identification. Example, handles and these materials which are molded cannot be recycled. Here this polyethylene, HDPE, high density polyethylene, and PVC, LDPE, polypropylene, polystyrene and others comes under the thermoplastic category, which can be heated again. On heating, it becomes softened, again cooling and molding. So the process is repeating again and again. That is called the recycling of plastics. So what are the difference between these two? These can be synthesized by a process called addition polymerization. So here the reaction involved is free radical mechanism. So by the addition polymerization, these thermoplastics are prepared, whereas thermosetting plastics, it undergoes condensation polymerization. Means here addition means it may be anionic, free radical, anionic and cationic addition will be takes place. So the active site may be the free radical or negative charge or positive charge. So suppose A is formed, means A plus A free radical will be formed. This go and attach another molecule of monomer. It breaks. Again it will give A dot. Then it forms a bond. So the resultant will be A. So this is free radical. If same way, if it is a negative charge, same here negative charge. If it is positive charge, positive charge. So they form a reaction like addition. They keep on adding the monomer units. This is addition polymerization. Whereas in condensation polymerization, so if it is A plus A, some hydrogen bonds or OH bonds present on this monomer units, they combine and remove these molecules. So they result in the removal of mineral acids like HCl or H2O. They form a bond between. So the bond is formed between by the removal of this water molecule. Then the monomer is formed. The polymer is formed by the combination of two monomer units. This is the condensation polymerization. It happens in the functional it happens by the removal of the functional groups or some small molecules from the monomers. Here this addition reaction generally takes place in unsaturated molecules, means whether the monomer should have double bonds or triple bonds. So here it is one monomer. This monomer means it should have some double or triple bonds. The breakage of the bonds result in the formation of free radical or it may also give anion or cation. So the reaction proceeds in such a way like they act as active sites and go and attack on the another monomers, and then it activates that monomer. It keep on adding, giving the addition polymerization reaction. So the thermoplastic is processed generally by injection moldings and extrusion process, and also blow molding, thermoforming and rotational molding. So the molding of these plastics happens in this way. Whereas in thermosetting plastics, it is due to the compression molding. Reaction injection molding will be there in thermosetting plastics. They have secondary bonds between the molecular chains. Here thermosetting plastics are primary bonds between the molecular chains and held together by crosslinks. As we know, they are very rigid because of their crosslinks. Here, they have secondary bonds. So, these between the molecular chains. Here, the primary bonds between the molecular chains are held together because of the crosslinks between the two polymer linear chains. The thermoplastics have low melting points and low tensile strength. This gives the advantage of recycling or remolding because of the low melting points and the low tensile strength. Whereas in thermosetting plastics, it have high melting points and high tensile strength. Thermoplastic is lower in its molecular weight compared to the thermosettings, and here thermosetting plastics is having very high in molecular weight compared to the thermoplastic plastics. So the properties. See, this can be remodeling, recyclability and high strength and shrink resistant and flexibility. Here thermoset materials are heat resistant, corrosion resistant and high strength, and the mechanical creep resistance is observed in thermoset materials. The great strength to weight characteristics. It having high weight because of more chains and more crosslinks between the two linear polymer chains. This gives the high strength and mechanical creep resistance in thermoset materials. So these are the bonds between the two linear molecules are the secondary bonds, and they can be reversible. There are no crosslinks between the chains, and thus it softens and remolds and recycled when heated. Whereas in thermoset materials, due to the presence of dense crosslinks, it gives the rigid structure. The chemical bonds cannot be reversed, means irreversible. They have strong covalent bonds between the polymer chains, which increases the crosslink density and thus it becomes resistant to heat. What are the examples of thermoplastic and thermosetting materials? The polycarbonate, polyoxymethylene and acetyl homopolymer, acrylic, nylon, polyethylene, polypropylene, polystyrene and PVC, polyvinyl chloride and Teflon comes under the category of thermoplastic materials. Whereas means they are remolded. All these polymers are remolded or reshaped on heating. Whereas thermosets, vulcanized rubber, bakelite, polyurethane, epoxy resin, vinyl ester resin, polyester, polyurea, melamine, silicone and urea-formaldehyde comes under the category of thermoset materials, which cannot be recycled, reshaped on heating. No recycling, no reshaping, or we can't even on heating, it won't. The chemical bonds are very strong and they are irreversible. So what are the advantages of thermoplastics? The primary advantages of thermoplastics are because it was applied in various projects because of high strength. They are lightweight materials, can replace metals, thus also exhibiting a weight saving advantage. They have relatively low processing cost. The primary disadvantage of using thermoplastic versus metal in their relatively more melting point, if they are exposed to sun for a longer time, they are generally regarded as low quality thermoplastics. They have poor resistance to hydrocarbon organics and highly polar organic solvents or highly polar solvents. They have the poor resistance. They can degrade easily. They are not creep resistant as like thermosetting plastics, which leads to weakened plastic parts when exposed to long-term stress. So the mechanical strength won't be there. So the mechanical creep resistance won't observed in thermoplastics. It gives the poor creep resistant and weakens easily when exposed to mechanical stress or strength. So what are the application of thermoplastics? They are widely used in automotive industry projects. Polypropylene demonstrates strength, stiffness and thermal capacity which is why it is widely used in the manufacturing of automotive bumpers and battery boxes. The rigid polyurethane foams are often used for insulation purposes, and flexible polyurethanes are used for the preparation of or the manufacturing of the car seats. So ABS, this is on the other hand has a shiny and impervious surface which is popular choice for manufacturing of dashboards, covers, car and interior linings. So this is the popular ABS plastic is the popular choice because it is used for all the manufacturing, all the automotive or the cars, road vehicles generally have this ABS plastic on their like covers, car and interior linings. This ABS is preferred and used. The polystyrene, polypropylene and PVC, polyvinyl chloride, this is PS, PP and PVC. Shortcut forms are good thermal resistance. These three have some good heat resistance, thus widely used for manufacturing of electrical insulation products. So the high degree of purity, recyclability and excellent elasticity, the ease of sterilization, which is why they apt for manufacturing medical equipments like syringes, medical tubing and glucose measuring devices and disposable surgical gloves or surgical gowns are used this polymers. Then used to manufacture in parachutes, conveyor belts, seat belts and tarpaulins are made up of this thermoplastic polymers. Polypropylene sheets and polyamide sheets are very less weight. They are safe and hygienic, which is why they are used in the manufacturing of storage and as in medical packaging, also in food packing. So what are the advantages of thermosetting? So now we have seen disadvantages, advantages of thermoplastic. Now we move to thermosetting plastics. They retain their strength and shape when heated. It makes them well suited for projects that require the production of permanent compounds and large solid shapes. So the thermosettings, as we know, we cannot be recycled. So once they heated and melted, they can be used for the permanent structures, which is having high strength. Because they retain their shape and strength once molded, the very large and solid shapes can be done with this thermosetting plastics. The thermoset plastics have excellent strength attributes. They do not lose strength even exposed to the high temperature because they cannot be remolded. So even on applying the pressure, it won't retain its shape. So even for the long exposure of high temperature also, it won't retain its shape. So what are the disadvantages of thermosetting plastics? The material properties of thermosets are not developed as those of thermoplastics. One of the first disadvantages of thermosetting polymers is the low initial viscosity of materials, which causes the secondary operations. So the low viscosity of the materials in the thermosetting plastics causes the secondary operations. They also have low tensile strength and ductility in plastic parts. They require design with thick walls. What are the applications of thermosetting plastics? The glass reinforced polyester thermosets are widely used in the automotive industry. To manufacture some panels like body panels, seats and interior components are made up of thermosetting plastics. The parts which should have the permanent structure and which should have high strength are made up of thermosetting polymers, which is like lightweight and less strength and should be flexible. These thermoplastics are used in automotive industry. So the epoxy or carbon fiber composites are often used to the manufacturing of some sports equipment like tennis rackets, golf clubs and other ski equipment are made up of this epoxy and carbon fiber composites which are from the thermosetting polymers. Wide range of applications such as sinks, shower stalls, doors, wall panels and window frames and even swimming pool linings are made up of thermosetting plastics. So this is all about the thermoplastic and thermosetting plastics, and which can be recycled are called thermoplastics, which cannot be recycled or reshaped or reformed. Those are called thermosetting plastics. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.